Good evening, everybody. Welcome to the nighttime edition of Chem 1105 with your host, me, Dr. White. This is a special Thursday night only this semester, I hope. I had some personal stuff that popped up that I had to take care of this afternoon. I apologize, but this way I didn't cancel class. I'll still get it in. All right, couple important things. One, I found a clarification, but my mistake. Let's go to student view. All right. One of the things I didn't realize I had the wrong one. In the safety contract, you should fill out the COD DL lab safety contract. If you have submitted the old one that said DL lab safety contract, please fill this out. And later tomorrow, I'm going to change this and I'll give you till Sunday to get the right one in, and you'll still get your 3 points. So be sure to download COD DL Lab Safety Contract, sign it. There's 2 pages. Each page you got to sign. Remember, my name is Dr. White. I'm the instructor. Hopefully you know your name, and upload it. And I'm going to change this, not right now. Instead of today, I'll give you till Sunday to get it on. And don't forget the safety lab is due today, or try and at least get it in. All right, how come I don't see it? Uh-oh. Let me do this. Let me do this. Keep your eyes closed. This is secret stuff, not really. That's why. I forgot to change the dates. You can see all the secret stuff faculty do. Let's see. Today is the 15th, so let's do this day. Oh, let's make it 8 p.m. See all the fun stuff Dr. White gets to do. All right. I hope everybody submitted it. If there's a problem, I'll get back to you. You'll still get your 3 points. All right, let's go back to student view now, and I fixed everything that I forgot to get the dates right. Let's go to assignments. And there is lab number 2. All right, are you all ready for a lab? A real lab. And this is important. Most of the labs, and I'll have it written on there, you can see it. Be sure to include a selfie of you with a chemical or a piece of equipment used for this lab, or you will get 0 points. This is a Department of Chemistry rule that I follow for online labs like this. You have to take a selfie. In this lab, if you take a selfie with your Alka-Seltzer or your thermometer, that will work. All right, let's talk about today's lab. And as you see, let me make this a little smaller. You can see today's lab. And this is the first page. You can download this PDF file. And it's got the really interesting name, Faster Plop Plop Fizz Fizz. That's from an Alka-Seltzer commercial, which I think most of you have never seen, which is Plop Plop Fizz Fizz. Oh, what a relief I had today, or something like that. But anyways, this lab deals with a very important concept. That's called the scientific method. How do we approach something to solve a problem or understand something in chemistry? We use the scientific method. Now, in this lab, you're going to be using some neat stuff. It's a fun lab. Students have liked it. We did this last semester in 1105 for the first time. 2 semesters ago, we did this in similar one for 1211. Actually, the same one. Now, when we're looking at things, we observe things. And then what is responsible for this observation? And what scientists do, and I'm a scientist, chemists are scientists, you make an observation as you see in figure 1. You ask a question. You develop a hypothesis, some reason or explanation of what's going on. Then you design experiments to test this hypothesis. You run the experiments, collect data, you analyze the data and see if your data supports the hypothesis or not, and then you revise your hypothesis if necessary and run more experiments. Now, I've had to do this. One of my jobs when I was in industry at 3 of the companies I worked for, actually every company I worked for. Hold on, somebody has a question. I see. Okay, is I had to solve problems that our customers were having with our product, or at our plants when we were having problems. And some of them were pretty tough and made my life very miserable because the president of the company would be calling me up, have you solved it yet? Because millions of dollars sometimes was on the line. And I'd make an observation, have a hypothesis, design experiments, and run experiments and see if it solves the problem. And if it didn't, you go back and develop a new hypothesis and set up design to run new experiments. And you try and do that in industry as quick as possible because time is money. Now, when we're doing experiments, we have variables, things that can change. Now, there are different types of variables. One is called the independent variable, and that's in an investigation, that's a variable that can be measured, and more likely you can control it. Example is, if we set in a hypothesis at this time of the day, it's light out or dark out. Well, I can control what time of the day I look out my window to see if it's light or dark out. So time would be an independent variable. Also temperature. If in the summer I put a bottle of water outside my back door and let it sit overnight, is it liquid or solid in the morning? And I could do the same thing in the winter when the temperature is colder. And I could find at certain temperatures that water will freeze. And we'll learn other things throughout the semester. Now, there's also what's called a dependent variable, which you measure. And the dependent variable is dependent, that's why it's called dependent variable, on the independent variable. In other words, if you pick a certain time, what will happen to the dependent variable you're measuring? And I have here, if I change the dependent variable from X to Y, what happens to the independent from X to Y? What happens to dependent? And we do these, and you can have different ones. And here they give some examples of also control variable, which is non-independent and shouldn't change at all. Now, what they don't explain here is when you're running an experiments, group of experiments, doing research, you should only change one variable at a time. And that's something a lot of chemists forget to do. I've had chemists working for me that I had to teach them that lesson, and I wasn't too happy. They wasted time not knowing that. Because if you change two things at one time and it works, which of those made it work? If it didn't work, you didn't get the answer you're looking for. Which of those two caused that problem? That's why in an experiment, you only change one variable at a time. So what are we going to be looking at, or more than likely you are, and that's using Alka-Seltzer. And here's the equipment you're going to be using. You have a 250 milliliter beaker, thermometer, a wax pencil, and the plastic cups. Now, in your kit, you should have this. It's a holder, and inside, if you open it up, this is a nice one, nice holder, you'll find the thermometer. Now, these are thermometers for chemistry or science, not a medical thermometer. You do not have to shake this down. You just stick it in there, wait a little while, and read the temperature. Now, you should be able to get three significant figures. If it's between the line that's 25 and 26, you can call it 25.5, and that's three significant figures. If it's right at the line of 25, I don't know if you can see it, probably not. If it was right at that line, exactly on it, this column of alcohol, we no longer use mercury in thermometers, it's not safe, that would be 25.0. Now, your thermometer should have this little triangle on it. And what that does is helps it sort of from rolling off onto the floor and breaking, which is not a good thing. This is glass. Be careful with it. Now, even though you have this thing on here, when I put this on a countertop, I'd put a paper towel underneath to keep it from rolling off, even though this should do a good job. Still, I like to play safe. All right. So we have our thermometer. You'll have a beaker here. And if you look here, they're numbers. And those numbers are volume. And that's in milliliters, which I'll teach you more about today later when we get in there. And when you want to measure 200 milliliters, you'll have it right up to this level 200. Now, for this lab, you don't have to spend 20 minutes trying to get exactly 200. If you're a little above or a little below, that's okay. If you're supposed to be at 200 and you're down here, no, put more water in. If you're supposed to be here and you're up here, pour some out. Now, in the lab, I think they say use DI water. Use tap water, it'll work all right for this lab. Here's a grease pencil. I think you're all familiar with this, how to pull the string to get more of the tip. And your cups in your kit, you can label that you'll be doing. Now, listen carefully. With all labs that you're working with chemicals, and water is a chemical, and Alka-Seltzer is a chemical, wear your safety goggles. You should wear. Now, these are ones that COD gave to all faculty to use when we're face-to-face. your kid has a good pair of safety goggles. The other thing you should be wearing, gloves and your rubber gloves. And your kit gives you nice pairs of those. Now, if you want to wear an apron that you have in there, that's fine. If you don't, that's okay. Also, remember, like I said last lab, use aluminum tray. It makes your life easier on cleanup in case you spill. And let's move on. So what are you going to be doing? You're going to be doing an activity 1, temperature versus time to dissolve. Now, what you're going to be doing, and this is in the file you can download in the Blackboard for this lab, you're going to have 3 cups, and you're going to label them C for cold, H for hot, and RT for room temperature, using, they call it a wax pencil. Back when I learned about this, we called it a grease pencil. All right. Now, you'll need some sort of timing device, such as a stopwatch, which most of you don't own, but a cell phone. Remember, keep the water away from your cell phone. Cell phones don't like a lot of water. Now, you're going to need to make an ice bath. Take some sort of container, fill it with about 300 milliliters of water and a bunch of ice cubes, and let it sit for a little while. Now, here they ask you to open this up, the packages of the Alka-Seltzer, and then break each tablet in 2. Here they tell you how to do that. Now, when I've had to break pills in half, when I was taking medication, I only have to take half a pill. I have a very sharp paring knife that I would use, and the advice they give you here in the tip, I would follow. All right, now, using the 250 milliliter beaker, measure 200 milliliters of room temperature water. And what I would do is take some cold water, just water, regular water out of your tap. Before you do the lab, let it sit for a half hour in a container like this. And then you can get get a bigger container, like a whatever you have in your house. I think most of you have the plastic Ziploc containers, not the bags, containers for putting food in. And you can put some water in there and get a second one or bowl for your ice. And then what you'll do is take 200 milliliters, pour it into the cup, measure the temperature, let the thermometer sit in there for about 30 seconds or a minute. And then what you'll do, and you can do each one of these separately. You have hot water from your hot water tap, put 200 milliliters using this beaker into the cup labeled H, and you can put the ice cold water, 200 milliliters, in the one cup that has C. And you measure the temperature for each one by putting your thermometer in there. Now, when you're ready to run the reaction, carefully drop an Alka-Seltzer tablet, half of one, not the whole one, into the cup with C, and immediately do the same with RT and H, and start your timer. And observe what happens in there. The bubbles. Don't tell anybody I gave it away. Hold on, somebody had a question. Now, let's see. This lab will be due next Tuesday. Who asked the question? Tulane asked that question. That's a good question. Every lab is due the next lab period. If we have a lab on Thursday, like now, it's due next Tuesday. Tuesday's lab are due on Thursday. So whatever day you have the lab, Tuesday or Thursday, the next time we have a lab is when it's due. Let me restate that. All Tuesday labs are due on Thursday, the next Thursday. All Thursday labs are due the next Tuesday. Everybody straight on that? Give me a thumbs up You're straight on that. Okay. So you time it until you keep on timing it until all of it has disappeared. And once it's disappeared, you look at the time and you write it down. Now, the first run, you're going to put a half a tablet in the cold water, room temperature and hot, measure the temperature, and then record the time. Now, anytime you do experiments, you never just do one. You do it in duplicate or triplicate. In this lab, you'll do the same thing again in run 2. You'll take the 3 cups and you can empty these out, rinse it out with water, and then all this liquid you generate can go down the drain. It's safe. You'll put in 200 milliliters of cold water in 1 cup C, room temperature in RT, the hot in H. And you'll put in, real quick, half a tab in each one, start your timer. That's my old stopwatch I used to have. I don't know where it ever went. Or go like this on your cell phone, and you record how long the temperature and how long it takes before you put the Alka-Seltzer in, record the temperature again, and then have the time until it all disappears, which means it's called dissolves. And you'll do that a 3rd time. Now, if you look on this table 1, we have average. Average is where you have each reading for a certain type of independent variable, and you add it up and you average it. Now, let's look at the average for, I can't write it on here. So let's go to my whiteboard. Oops, I did something I shouldn't have. Bad, Dr. White. I did script or cursive. And you're going to have numbers here. Let's call that A, B, C, D, E, F. For the average temperature, you take A plus B plus C and divide it by 3. For the average time, you take D plus E plus F and divide that by 3. And that's how you do that. And you'll do the same thing for the hot and the room temperature. That's not what I want. That's what I want. All right. Can I have everybody's attention? You don't have to do activity 2. If you want to, I'm not going to stop you, but you don't have to do activity 2. If you'd like to, but just doing activity 1 is enough for this lab. I'll keep you busy. All right, now let's look at the lab report for this lab. And you'll see that also in the assignment area. In fact, let's go there. See where it has scientific method Q, both as a PDF, that means questions. The Q as a MS Word document and a PDF. The ADA are your instructions that I just went through. Now, if we open up here, scientific method, the questions, it will look like this. and you'll recopy your table in here. Now, you'll be using graphing software such as Excel to graph the results. Now, what are the two variables that you would graph? Hint, TNT, hint. All right, which should be on the independent on the X? Which one do you control? Temperature or time? Temperature. And therefore, that's going to be on the X-axis. And what are you measuring? The time. That will be on the Y. I'm giving you all the answers. Now, let me talk about something. I could do it tonight, but everybody see on the screen, you have, first of all, in the questions I just went through, you'll do questions 2 through 8. Also answer the question after table 2. Now I also put down here these two videos. This is when I first did it for Chem 1211. I did a good job explaining it. Will help you with the lab. And in video, the second one, if you start at 1141, that will show you how to graph with Excel. Let me just show it to you. I won't say any more. With a thermometer, and you just plop the Alka-Seltzer in there, and it may be fizzling a little, fizzling. Morning, I forgot to with your lab report. All right, now your lab report, someone asked, you can either type it, because this you don't have to draw anything, type it out into Word and upload that, or if you can print it out, write your answers in it by hand, and then upload that. You have ability to open up a PDF file. You can type it in that and upload it. All right, what I like to do right now is show you how to graph in Excel. You can do this on regular paper, and I just uploaded this morning. I forgot to, the Carolina company, they have a PDF how to graph. I won't say anymore. If you already did it, email me the photo. You should be able to still upload stuff the way I have it set up in Blackboard for labs. You can upload more than one thing at one time or different times. It's not one chance and you're done. All right, thumbs up, people. Everybody see temperature? The spreadsheet on your screen. All right. If you do not have Excel and you want to graph it using Excel, COD provides free access to Microsoft 365, which is the, how should I say, smaller version of Microsoft Office. I personally have my own copy of Microsoft Office, as you can see in the upper corner here, because I use it for my work and other things, and I've been using it for, I'd say, this many decades. Oh, shouldn't have said that. All right, now for the lab we're doing, that's due next week, and you have to graph. Don't forget this temperature, Tuesday. You take the average. The cold one, you take the average of two temperatures, and you take the average of two times, and this is an average right here. And you do it for the 3 different temperatures. I made up some data here just to show you. So I have temperature, time, put the numbers in. You highlight it. And you can go back and look at this video after I post it later today to see how to do this, click on insert. Then the easiest way is click on recommended charts. Again, click on insert. This will come up, this menu. Click on recommended charts. You want scatter. And that's the first one. See where this is different ones? Click on scatter, click OK. Again, insert, then recommended chart. The insert chart will show up, and click on scatter and click on OK. Now, let me Now, over here, we have our graph right here, but here's something I found out. I haven't done graphs in a long time. Organic chemists don't do that many graphs, but click on change chart type, and you'll see different things. And if you click on each one line, you'll see different lines you can do. Pick the first one, which I did, hit OK, and you notice you got your line. Now, the other thing, click on plus if you want, and where it says axis titles, you now have the titles. If you click on the title down here, and that would be temperature, and click on the y-axis, and that would be time. And now this whole graph, you can copy, and then for your lab, either you can print it out like that and include it in your lab, or let me get to a new, I'm in a Word document now, and I did Control-C copy. I'm old school. I love to do keyboard shortcuts as opposed to using my mouse. And now I did Control-V, and I've now posted that in. Now, one thing I forgot to do, and I'll do this, is this title. You can put down lab graph or whatever you want to call it. And that's how you do it. So let's go through this again. You put in your data, use the averages. Then you highlight it. You go to insert. Then you go to recommended charts. And then you want the scatter. And then you hit on OK. And then once you get this in, you can get to, which I don't see it right now. When you do it, you'll get to where it says change things, click on that, and you can pick on the scatter with this line. And then this plus over here, you click on axis titles, chart title, and grid lines.
What about if I don't have a plus?
You don't have a what?
I don't have a plus next to the chart.
Huh. Well, did you highlight? All right, here's what you did. Yours looks like this, right, Anna?
Yes, I just don't have
All right, now put the cursor over the graph.
Hold on.
And click on it. You see how you see the little circles around the graph?
Yeah.
That's when the plus shows up.
No, I don't have a plus.
Well, I'll tell you what, come to my office out anyways, you can look at that video. So you can answer these questions. Now, once you have the graph, it asks how many seconds would take to dissolve an Alka-Seltzer tablet in water at these temperatures. And what you do is you look on your graph and you have the temperature on the X and you find 35, you go up and you see where it hits the line, then you go over to the Y-axis and you get the temperature. Now, like I said, you don't have to do activity 2, but don't forget at the very end, this question right here, what could have been done in your activity? Hold on, maybe I didn't. In either activity to make the results more reproducible. Now, someone had a question.
Yes, I have graph paper. Is it possible for me just to do it in graph paper?
If you want to do it on graph paper, you can do that too.
Okay,
That's
thank
the
you.
old school way. I used
Yeah,
to do that in high school and college too, because we didn't have computers back then. Ooh.
yeah, I think I would
Oh, we
take.
had computers, but not home computers.
Okay, thank you.
Now, when you're done with today's lab, make sure you rinse off your thermometer with some cold water, dry it with a paper towel. Be sure to put it back in its container. By the way, they give you a really nice, this is a really nice container. And these rinse out. You may want to use them again. I don't remember. This rinse out and dry out and save it for the next lab. And this lab is due next Tuesday. Thursday's labs are due to next Tuesday, and Tuesday's labs are due to next Thursday. Any questions? All right, let me clean up my lab area. Also, as always, when you're doing a lab, before and after, wash your hands. This is good SOP. SOP, in case you don't know what that stands for, standard operating practice. Let me make this a little larger. Do we need to copy the graph to the Word, or, well, you can do it either way. You can submit it. Here's what I like you to do. Try and copy it into your lab report. If you're having problems, just copy it onto a blank page in Word and print that out and scan it and have it all in the same PDF. Okay? What I don't want, and I was just thinking about it, is for you to upload an Excel spreadsheet. It just makes my life harder. And the summer, with all it being quicker, and even in fall and winter, I don't need things to make my life harder. I guess either do you too. Any other questions? And don't forget, you can always email me at whitek@cod.edu with questions. And you can also come to my office hours on Monday and Wednesday night. And let's continue with our nighttime edition of Chem 1105 with your host, me, Dr. White. See, I'm both a morning, afternoon, and evening person. Actually, all my life, I said you learn a lot. Since I've been about 7 or 8, usually I go to bed about 11:15, and usually I get up by 5 o'clock. That's I've done my whole life. All right, let's go back to, I see a question. I see everybody says okay. So let me move on. All right, let's go back to Appendix A2, A4. And we're talking about multiplication division using significant figures. Remember, last class yesterday, I went through how to determine significant figures. Hint, practice that, do the practice problems. Now, when you do multiplication division, the same number, you get the same number of significant figures in the answer. The number of significant figures in the answer is the same as the number of significant figures in the measurement, the number you're multiplying or dividing, that contains the fewest significant figures. Again, when you're multiplying and dividing, you get the same number of significant figures in your answer as the number you're multiplying and dividing that has the fewest significant figures. And if not, well, you round it off. So let's do some practice on this. And the question would be, you're doing a problem and you have to multiply 3.145 times 10 squared times 2.1 times 10 to the 6. Well, hopefully you have your trusty calculator. I'll do this, and I'll put in 3.145, blue key, double E. Remember, I showed you this in the video yesterday, 2 times 2.1, blue key, double E, 6. I hit enter, and my calculator gives me this number. And if you write that down, I'll take off a point, because on tests 1, 2, 3, and 4 in the final, underneath your name, will say, please use proper significant figures for all calculated answers. Well, what do? Well, you look at this number and how many significant figures? All non-zero numbers are significant. 1, 2, 3, 4. This has 4 significant figures. We look at this number. How many significant figures? All non-zero numbers are significant. This has 2 significant figures. Now the hard part, which one of those is a smaller number? And time's up. Hopefully I'll pick 2. Therefore, our answer should also have 2 significant figures. Well, what do? Will you round this off to 2 significant figures? Keep the 6. Keep the 6. Remember, we have a decimal. The next number you use to round off, that's a 0. When it's 4 or less, you drop the number and everything afterward. So the correct answer here would be 6.6 times 10 to the 8. Remember, when you multiply and divide, you get the same number of significant figures in your answer as the number you're multiplying and dividing that has the fewest significant figures. And notice this has 1, 2, 2 significant figures because we rounded it off. All right, let's do another one. And the question is, what would be the correct answer using significant figures multiplying 8.11 times 10 to the 7 times 6.345 times 10 to the 3rd? This is a 3. So I'll clear my calculator. 8.1, blue double E, 7. That's how you get the exponent 10 power times 6.345, blue double E, 3. And my calculator gives me this number. And it gives me 5.145795 times 10 to the 11th. Well, that's not the right answer using significant figures. What we need to do is your answer should have the same number of significant figures as the number that you multiply and divide that has the fewest significant figures. In this one, all non-zero numbers are significant. 1, 2, 3. 3 significant figures. All non-zero numbers are significant here. 1, 2, 3, 4. 4 significant figures. Which one of these is lower? And time's up. Hopefully I'll pick 3. So my answer should have 3 significant figures. Well, it has more. So how do you round this off? Keep the first significant figure, second, third. That's my 3 significant figures. The next number I use to round off, the 5. Is that 5 or higher or 4 or less? Well, it's 5 or higher. So I'm going to drop everything after that and increase the number in front by 1. And that's how you get significant figures. Notice now this has 3 significant figures. Now, if I look at the clock, oh no, it's time for a break. Let's take a 5-minute break. Don't fall asleep on me. I know it's the evening, but it's early in the evening, unless you got up real early. And I'll be back in 5 minutes because I'm going to get up and stretch. So I'll see you in 5 minutes and we'll continue on. Oops, I took a little longer than a 5-minute break. Sorry. Let's get going. Let's get moving. All right, let's get back to what we were doing. When you multiply and divide, you get the same number of significant figures in the answer. The answer is the same as the number of significant figures that you're multiplying and dividing that has the fewest significant figures. Now, let's look at the following. 6.7892 times 10 to the 5th divided by 3.413 times 10 squared. So 6.7892 blue double E 5 divided by 3.413 blue double E 2, and my calculator gives me this number. Are you ready for this? 1.989276971. Nope, hold on. That last one. 697, 1.989217,697 times 10 to the 3rd. Now, I'm going to let you figure out what should be the real answer for that. Remember, you have to find out how many significant figures in each of these numbers. Whatever is the lowest number, then you have to round this number, which has 2, 4, 6, 8, 10 significant figures. Wow, your turn. Am I nice or not for sharing? Don't answer that. And I can ask the following poll, say yes when you're done or vote yes, so I know to get moving. And it looks like everybody's done, so I better get moving. All right, how do we do this? Well, you have to find out how many significant figures each number, in this case, you're in your division. All non-zero numbers are significant. 1, 2, 3, 4, 5. The top number has 5 significant figures. The bottom one, 1, 2, 3, 4. Which one of these is a smaller number? And hopefully all pick 4. So now you have to round this number to 4 significant figures. Keep the 1, keep the 9, keep the 8, keep the 9. That's 4 significant figures. The next number I use to round off. That's 2. Is that 4 or less or 5 or higher? Hopefully all pick 4 or less, which means I drop this and everything after it. And the correct number would be 1.989 times 10 to the 3rd. Let me do that again. This has 5 significant figures. This has 4 significant figures. The number that's the lowest significant figure, 4, is how many significant figures your answer should be. And to round it off, we keep 1, 2, 3, 4. That's where we get that number from. We use the 2 to round off. That's 4 or less. So everything after the 9 we drop, and this is our answer. And that's how you do it. I have a question, so let me check what it is. Oh, I see somebody had the right answer. All right. Does anybody need me to do one more? Give me a thumbs up if you want me to do one more. And it has been requested. Now, I'll do the calculator part, but you should know how to do this. Watch yesterday's video to see how to use scientific notation calculator. If you're having problems, come to my office hour or email me if you need a private Zoom meeting. All right, so let's do this division. 2.00 blue double E 5 divided by 1.6 blue double E. Now, don't forget, use the minus sign here, not this minus sign, the one on the keypad for minus exponential, minus 3. I hit enter. And this is what my calculator gives me. Now, it's your turn to figure out how many significant figures should my answer have. Remember, you get the same number of significant figures in your answer as the number you're multiplying, dividing, that has the fewest significant figures. I see somebody's already done.
I have a question.
Go for it. I like
So
that. Go for it.
So would we round the 0.25 to 3? Like that's how we do it? We'd round it?
Well, let's find out.
Okay.
How many significant figures is 2.00? All right.
One?
Nope.
Wait.
That's
Oh, wait.
I put it down. I caught you, and I think I caught someone else. And Dr. White can be sneaky. Watch out. I can be sneaky. All right. How do we do significant figures? All non-zero numbers are significant. That's the 2. All zeros at the end with a decimal point. Ooh, look what's there. A decimal point. So these 2 are also significant. So this would have 3 significant figures. Oops, wrong color. I'll say that again. Zeros after it at the end of a number with a decimal point are significant. So this would have 1, 2, 3 significant figures. Now at the bottom here, all non-zero numbers are significant. So, and you might have been right, but anyways, that's 2. I just wanted to catch you here. So which of these is a lower number? 2. So you were right. How many significant figures should our answer be? It should have the same number of significant figures as the number that has the fewest significant figures, and that's 2. So how do we round this off to 2 significant figures? It's got 3. Keep the 1, keep the 2. Use this to round off. Is that 4 or less or 5 or higher? 5 or higher. Drop that, increase this by 1, and the answer would be this. So does that answer your question?
Yes, thank you.
You're welcome. And as you see and have seen in my class, In my world, there is no such thing as a dumb question, and a student of mine should never, ever have to feel bad or sorry or any other thing bad, negative about asking questions. They're encouraged. They help you learn, which is a good thing. All right, let's move on to addition and subtraction. Now, addition and subtraction, and this class, I don't think we do any subtraction, but later in the semester, we'll do addition. And I'm going to have to come back and teach you this again because you probably forget it, but I will come back and teach this. Your answer has no more digits, which is another way of saying significant figures, to the right of the decimal point than are found in the measurement with the fewest digits, significant figures, to the right of the decimal point. So what does this mean? This looks confusing, and it is. It took me a while when I first learned it to get it right. All right, if you look on the screen, we have an addition. And if we add it up, we get 5.51, which is not the correct answer. You say, what? Well, when you do an addition, you get the same number of significant figures or digits that are right in the decimal as the number with the fewest digits, or I call them significant figures. They're all significant. This has 1 to the right of the decimal point. This has 2. Which number is smaller? And hopefully you picked 1. So now we have to round it off. So we only have 1 number to the right of the decimal. Keep the 5, use the 1 to round off. Is that 4 or less? Yes, so I'm going to drop it. And the correct answer using significant figures for that addition is 5.5. Let's do this one. If I add it up, and make sure I do this correctly, if I ever make a mistake, let me know. Ooh, that reminds me, do I have time? I do. When I was in undergrad, we had this, I had almost all but one professor out of my 4 years at IIT were really good. I mean, really good. And my first semester sophomore year, I was taking partial differential equations. It was a tough course. And our professor was Professor Dr. Pearson. He had a nickname, Machine Gun Pearson, because if you ever heard those commercials where the guy talks real fast, and even faster than I'm talking right now. But anyways, he talked that fast. And one time, the first day, someone said, can you talk slower? And he said, no, you better learn how to listen faster. Turned out he repeated everything 3 times. So if you missed the first time, you got it the second or third time. But anyways, he gave a whole lecture on the board, 40 minutes, using partial differential equations to determine the volume of a sphere or something that was a known formula. And he got the wrong answer. And this was in an old lecture hall where they had the boards that slide up and down, total of 9 boards, and he filled them all up. And he's looking and says, what did we do wrong? And everybody's saying, well, I don't know. After about 5 minutes, he says, see the first thing I wrote on the board? And he pulled down that board. That was garbage. And all of you should have pointed out that was wrong. Just because I write something on a board doesn't make it right. And that was a great lesson. And decades later, I still remember that lesson. Great professor. But anyways, let's get back to math. You get the same number of significant figures to the right of the decimal, or digits they call it, as the number with the fewest digits or significant figures to the right of the decimal. This has 3, this has 2, which is a smaller number. Hopefully you pick 2. So now we keep this one, and use that to round off. Is that 4 or less? Well, I did it again, it is. So the correct answer here is this. And let me give you one to try. Let's make that an 8. And what would be the correct answer here? You try it now. And please vote yes when you're done. Remember, you get the same number of digits or significant figures to the right of the decimal in your answer as the number with the fewest significant figures to the right of the decimal. I like my special effects. That must be late in the night if I'm pulling those kind of bad jokes. All right, everybody's done. Now, if we look at the first number, how many digits or significant figures to the right? And all numbers are significant after the decimal, and that would be 4. Here we have 1, which is the lower number, and times up 1. So we keep the 6, use the 8 to round off. Anything to the left of the decimal, you do not change, like this number. And here, this number is 5 or higher. So we're going to drop that and everything, increase this by 1, and the correct answer is 7.6. And that's how you do it. Now, we're not going to be doing addition for a while, a couple of weeks. And when we do start doing it, I will come back and teach you it again, because you probably will forget it. If you don't use something, you don't remember it. And I'll come back and teach it. So let's move on. Now, exact numbers are not considered when determining the number of significant figures in a calculation. When we get to that, I will remind you about exact numbers. All right, now let's talk about measurements. There are 2 basic units of measurement on our planet. One is called the English system, and one is called the metric. By the way, click, the switch is off. This won't be on a test, but it's good background information. In the United States, we use the English system. The rest of the world, except for England and maybe a couple of their colonies that I've never been to, I've been to England, but not to, say, Australia or some other countries, they use the metric. All of Europe, other than England, uses the metric. And I've been in Germany, the Netherlands, France. Never made it to Italy, or I stayed out of Eastern European countries, because back then they were communists. No, I didn't want to go there. All right, now the metric system, which we use in chemistry in the lab, in the plants in the United States, they actually use English, and in Europe they use the metric, but is the metric, and switches off. And metric comes from the Greek word metron, which means to measure. Now, for next couple slides, the switch is off. When we talk about length and metric, and I don't know why this got smaller scale. Oh no, the dreaded change your scale. Bug got my slides. All right. The main unit measurement for length in metric is the meter. And some important things, 1 meter equals 100 centimeters, and 1 kilometer equals 1,000 milliliters, meters. I got confused. And if you look on the speedometer of your car, the outside says miles per hour. And if you go inside, because the car might be sold, or you might go up to Canada where they have the metric system, that's kilometers per hour. Now, volume is liter. And 1 liter is 1,000 cubic centimeters, abbreviated this way. Again, switches off. 1 liter is 1,000 milliliters, and milliliters, which we use in chemistry, is ml. Liters is abbreviated by L. Now, on syringes and medical syringes, instead of using milliliters, they use cubic centimeters, but 1 milliliter equals 1 cubic centimeter. Again, click, switches off. Now, the metric unit for mass is a gram, and 1 kilogram equals 1,000 grams. If you watch movies like anything they're dealing with illegal drugs like cocaine, you'll hear in the movie or the TV, "Ooh, we're bringing 100 keys tonight at midnight by boat to come in." And what they say when they mean key, that's kilogram, that's slang for kilogram. Now, switches on, click. The prefixes like kilo, mega, giga, centi, milli, micro, nano are used, like milliliter is 1,000th of a liter. And you should know the following. You should know a kilogram or kilo prefix is 10 to the third. You should know a centi, like centimeter, 10 to the minus 2. And you should know milli, like in milliliter, is 10 to the minus 3. So milliliter is 10 to the minus 3 times liter, or 1,000th of a liter. Now, the others are important. If you have a computer, you know about mega, how many megabytes of memory, or giga, how many gigabytes. The computer I'm on, I'm a computer freak, yes, or a power user. I have tetra. And let's see. And tetra, you can see tetrabytes is a lot larger than, and I have my latest, I don't know if you can see right here. These are external hard drives, and last winter I got this 4th one, and that's 20 terabyte. It's a lot of memory, but then I do a lot of stuff in electronics and also video, like what you see on my YouTube. So I use all that. So you should know, if I ask on a test, what does the prefix kilo mean? Is 10 to the third. If I ask, what's the prefix milli? 10 to the minus third. Now, in the book, they talk about conversion factors and a method called dimensional analysis. The old name, which I like and I use, is unit analysis. And right now, switches off. And it's a way of determining how to go from one unit of measure to another. In other words, if you have a dozen eggs, How many eggs do you have? 12. Well, you can go unit analysis of, well, I have 4 dozen eggs. How many eggs do I have? And unit analysis helps you get there. And you should always, with calculations, use significant figures. Now, it's going to be about a week and a half or so, maybe even a little longer, until we start doing some calculations for problems. And you'll be using, as I call it, your good buddy. Doesn't want to work today, I'll have to fix it. Your good buddy, your good friend, unit analysis. And I learned unit analysis in high school. My high school advanced AP chemistry teacher was department head, Mr. Salners, who's a great guy, taught us unit analysis. I mean, we really learned it because in AP, we had to take the Westinghouse exam for the Westinghouse competition. Our high school is known for having the highest in the state, if not the country. I won state, but not national award in the Westinghouse. You had to take this test. And we were, for practice, given our exams where you only had 28 minutes to do it, and you were taught how to use unit analysis. And I've used it ever since, and I've used it in industry, and I'll be teaching you, and you'll find out unit analysis is your good buddy, your good friend. But I'm not going to teach it now, because if you're not going to use it for a while, you're going to forget it. And that's what I'll be teaching you. It's a general problem-solving method. And your lecture will cover this, later when it's needed. Now, let's talk about something called density. And this won't be on a test, but we'll have it on the lab. And density measures, by definition, mass per unit volume. Mass of a substance per volume. And the interesting thing about density a more dense object will sink when put in a liquid of a lower density. So if you have a cannonball made of iron, and the density, I think, is about 11 pounds per, or 11 grams per milliliter, and water has the density of 1.00 grams per milliliter, you put the cannonball in a bucket of water, and guess our barrel water, it's going to go whoop, sink to the bottom. The other thing you should know about density a less dense object will float when put in a higher density water. If you take a feather, which has a density of about 0.001 grams per milliliter, and you put it on a bucket of water, which is 1.00 grams per milliliter, the feather is less dense than the water, and it floats. Same thing, if you remember, Everybody see on your screen? Let me check. I don't have to ask anymore. These are the old cork life preservers where you throw it to someone who's drowning. And why? Because they're made of cork. Cork has a lower density than water and it'll help someone float. And that's why these were used. And again, I will not ask density on my test, but I will have that in a lab we'll do later on. Oh no, we finished Appendix A2 and A4. And guess what time it is? It's time for a new chapter. Before we do that, I better open it up. I don't want too many things open or my computer burps on me. Doesn't like that. And the new chapter is atoms and atomic structure. All right, time for commercial from Dr. White. Remember chemical symbols. Remember that's 1 or 2 letter abbreviation for the names of the elements. Only the first letter, of the element is capitalized and the second letter, if there is one, is lowercase. I've only asked you to learn these elements from the periodic table. So if I ask on test, what's the chemical name of the element with the chemical symbol Li? It's lithium. What's the chemical symbol for mercury? Hg. What's the chemical symbol for bromine? Br. What's the name of the chemical with the chemical symbol N? Nitrogen. You should know those. Learn them this week and this weekend. Start memorizing them. Now, in this chapter, they have something about the mole and molar mass. This is not the time to cover it. That's why I don't like this book, because I'm jumping around to make more sense and make your life better. Don't tell anybody I'm being nice. Shh. Now, one of the things we will use a lot in this class is a chemical formula. And that's the notation made up of the symbols of the elements present in a compound and a numeric subscript located to the right of the symbol that indicates the number of atoms of each element present in a molecule. See board for examples. Oh, I better get to work. Now, an example of a chemical formula is this, which is water. And this tells me there's 2 hydrogens plus 1 oxygen. When there's no subscript to the right, that's 1. So how many atoms in water? 3 atoms. 2 hydrogen, 1 chlorine. Did it again. I gotta be careful. Well, it looks the same. This is called calcium chloride. Those are the little white pellets you put on your sidewalk to melt the ice when it's super cold out. How many atoms are in calcium chloride? Well, we see 1 calcium plus chlorine, Cl, but 2 here, so there are 2. So once again, we have 3 atoms. This is called the chemical formula for ethanol. That's the chemical in things like beer, wine, and hard spirits that if you consume too much, you get inebriated. Not that I'm recommending you ever consume those things. How many atoms are in ethanol? Your turn. Thank you, Yulia. Let's give everybody else time too. And when you're done, don't forget to vote. All right, my turn. So how many atoms are there? Here's carbon, and there are 2 of them. Here's hydrogen, there's 6 of them. Here's oxygen. Oh, no subscript, so there's 1 of them. If I did my math correctly, which I did, there's 9. Now, let me teach you something else. And that is something like this. This is called calcium hydroxide, also known as lime. And this should be a C. So there's 1 calcium. But see here the brackets, and it has a subscript. You multiply everything inside the bracket times what's outside. So that tells me there are 2 oxygen and 2 hydrogen. Again, when anything's in the bracket, you multiply everything inside by the number here. That means there's 5 atoms in calcium hydroxide. Now, let's do another one of these. And this is calcium nitrate. How many atoms are in there? Well, there's 1 carbon, 1 calcium. Then we have the brackets. So we multiply everything inside the bracket by the number outside to the right subscript. So 1 nitrogen times 2, 2 nitrogen. Now inside we have 3 oxygen, but we have this 2 here, so that would be 6. So 1 plus 2 plus 6 is 9 atoms in this molecule. And it's time for you to have some fun. How many atoms are in magnesium hydroxide? All right, let's go ahead and do it. We have 1 magnesium. Remember, you have no chemical symbols. Now, we have these brackets. Everything inside you multiply by the number here. In this case, 1 times 2, 2 oxygen, and 1 times 2, 2 hydrogen. And that tells me there are 5 atoms in magnesium hydroxide. Let's do 1 more. How many atoms in calcium bicarbonate? Your turn to have some fun. Well, I see somebody's really doing a good job. And when you're done, vote yes. And I guess everybody's done. There's one calcium. Now we have these brackets. And notice to the right subscript the number 2. So whatever inside, we multiply by this number. 1 hydrogen times 2 is 2. 1 carbon times 2 is 2. 3 oxygen times 2 is 6. And that's 11. So that's something you should know how to do. Now, an important, what would I say? Important thing in chemistry is the periodic table. And I'm going to turn the switch click off for the periodic law, definition of periodic law and periodic table. Now, the periodic law is when elements are arranged in order of increasing atomic number, elements with similar properties occur at periodic, regular occurring intervals. And based on that, chemists or scientists, I don't even think they were called chemists back then, came up with the periodic table. And I'll never ask on a test, what's the periodic law or what's the periodic table? But it's the tabular table, fancy word tabular, arrangement of elements in order of increasing atomic number in which the elements with similar properties are positioned in the same column. Now, I'll teach you later about atomic number, but first of all, I better open up a periodic table. I'm going to go a couple more minutes than normal because I want to get to a certain part. Please bear with me. And here's the periodic table that you'll be using for all your tests and final. And the number in the upper right-hand corner, I'll teach you this again, is the atomic number. Notice you have 1, 2, 3, 4, and so on. And everything in the first column, they have similar properties. Second column, we go over to column 7, fluorine, chlorine, bromine, iodine. Those are similar. And that's the periodic table. And I won't ask you, vertical columns are called group, horizontal columns are called the period. The groups are the most important to us on the periodic table, at least me personally. Now, there's certain classification of groups. Key groups, and give me about 5 minutes more and then I'll let you go. Just hang in there. Key groups in the periodic table have special names. And I'm going to be subtle. And know this. And those key groups are the alkali metals, the alkaline earth metals, the halogens, and the noble gases. And you should know which atoms in each of the aforementioned groups are in there. Let's take a look at this. In the first column, under 1 in red, excluding hydrogen, are the alkali metals. And for this class, you should know lithium, sodium, potassium are the alkali metals. Don't forget, I'm not asking you to learn the other ones in there, rubidium, cesium, and francium, which I haven't asked you to learn, but I know are also alkali metals, but we're not going to use those. I have never used any of those in my life, which means you won't either, most likely. Next column under the number 2, those are the alkaline earth metals. And calcium and magnesium, MgCr, Ca, are the ones you should know. Now, strontium, yeah, I played with that a couple of times, but and barium, but really not really. Now, if we go all the way over this way, under column 7, those are the halogens. Fluorine, chlorine, bromine, iodine. You should know those are the halogens. Under column 8, the number 8, those are the noble, the noble gases. When I grew up until the 1990s, those used to be called the inert gases, till one very clever chemist found a way to make them react by really beating them hard. But they reacted so they no longer could be called inert, and they were given the name noble gases. And that's helium, neon, argon, krypton, xenon. And on a test, if I ask you, give the name and the chemical symbol for a noble gas, you could put down Ne, neon. If I ask on a test, give the name and the chemical symbol for halogen, you could put down Cl chlorine, Br bromine, F fluorine, or I iodine. If I ask, give the name and a chemical symbol of an alkali metal, Na, magnesium, I'm thinking ahead of myself. Na, sodium, K, potassium, Li, lithium. And finally, if I ask on a test, 2 points each, give the name and chemical symbol for an alkaline earth metal, and that would be magnesium, Mg, or calcium, Ca. And with that, I'm done for the evening. And that concludes our special evening edition of, and I'll ask your question in a little while, of Chem 1105. We're done for today. We're done for the week. You survived the whole week with Dr. White. Yay! Hopefully you're watching the videos or anything. And with that, I'm going to say goodbye, but afterward, I'll stick around if anybody has questions. So I'll do what I've said. I'll say "Gehen gesund," which in Yiddish means go in health. And since the pandemic, I've always done that. And I'll also do this, "Gehen gesund," goodbye. I stole that from Granny and the Beverly Hillbillies.